A scientific controversy is a substantial disagreement, discussion, or dispute among scientists. A scientific controversy may involve issues such as the interpretation of data, which ideas are most supported by evidence, and which ideas are most worth pursuing. An example of a scientific controversy is the connection between race and intelligence. This debate has been present in both academic research and popular science since the inception of IQ testing in the early 20th century. Scientific controversy. The term controversy refers to a discussion often with opposing views and can be broad. A scientific controversy is more specifically a controversy relating to a scientific matter. It can be a disagreement among scientists or a disagreement among the public about a scientific matter. In a scientific controversy, it is typical that a method, theory, or hypothesis cannot be agreed on. These controversies influence how we interpret data and make conclusions that best fit the evidence and data. Scientific controversies are healthy and cause scientists to approach their work differently. For example, a controversy over a topic may influence a scientist to increase the precision of his/her work or collect extra data. In addition, a scientist may continue a study further if there is interest in the matter. Scientific controversies may bring media or general attention, allowing for awareness of the topic or issue being debated and often causing an increase in research. Because of this, scientific controversies aid in pushing scientific discoveries forward. The term scientific controversy can also hold a broad including political and philosophical controversies as well. Controversy between scientific and non-scientific issues. Occasionally controversies arise that involve both scientific and non-scientific matters. Scientific beliefs are based on systematic, factual conclusion while non-scientific matters can be based on beliefs, morals, senses, intuition, or experience. Controversy between the two occurs when scientific evidence opposes less tangible beliefs of a group or a society as a whole. An example of this is the controversy between religion and evolution. Scientists actively make discoveries about the history and evolution of humans while religion has preached often opposing records of this history for hundreds of years. Controversies like these cause people to make a decision based on how they value the source. Opinions are typically formed based on which information is accurate and right. This type of controversy has posed as a significant challenge in the United States school system because of the conflicting opinions on the teaching of evolution. Different creation standpoints hold different opinions on what should be taught in terms of evolution. Controversies involving non-scientific issues hurt scientific research because they influence people's beliefs and opinions on topics rather than observing the evidence. Controversies between scientific and non-scientific ideas are not within the realm of science and are not true scientific controversies. This is due to the absence of purely factual evidence. Types of scientific controversies. Two types of scientific controversies are most commonly seen: fundamental and secondary. Fundamental scientific controversies are controversies that are based on the main or central idea of hypotheses or theory. They focus on a core issue in the given field. For example, the validity of string theory, the next big leap into theoretical physics, would be categorized as a fundamental scientific controversy. Secondary scientific controversies, however, focus on the ideas that surround the main topic. One example is the skepticism in the general population if there is global warming, but in contrast, the majority of the scientific community agree there is global warming. This is a fundamental scientific controversy because it is the main idea. The real issue, the secondary scientific controversy, is how fast is it occurring and how to model it, which is what is being researched and debated. It is important to distinguish between these two so that the real scientific issue does not get missed. 1. Scientific debate. Scientific debate is based on evidence and factual information. Because of this, only experts are typically qualified to debate. The exclusion of non-scientist participants in debates causes a struggle for recognition of other significant issues such as economic concerns or cultural value of the environment. Scientific controversies and education. Scientific controversies influence education more than one would expect. Scientific issues relating to education can include research about the brain, the human body, or learning in general. Discoveries made in this category can be used to change the way educators present the information to students in an effort to maximize the information they retain. Teaching methods as well as their effectiveness are debated. One of the largest debates over education occurred in the 1920s when the issue of teaching evolution was up for discussion. Science and religion typically explain evolution differently, and this causes significant debate of which history should be taught. Scientific controversies are integrated into some U.S. schools' curriculum. Learning about controversy can be beneficial in challenging students' thinking and presents a relevant, real-world issue for students to discuss. While learning about scientific controversies, students can become more comfortable with education topics such as discussion, debate, and science and world knowledge. Scientific controversies and the public. Due to separate knowledge bases, scientists and the public have different opinions on individual controversies. One study showed that 87% of scientists believed climate change is mostly due to human activity, but only 50% of the public were in agreement with this statement. Opinion discrepancies occurred consistently throughout the study, following a pattern of significantly higher percentages of scientist beliefs than public beliefs. This gap is seen as an issue solvable by science communication, the process of bridging the gap between science and the public. Public acceptance of scientific facts is a starting point for the understanding of these controversies. Scientists themselves often are not the ones to communicate their research findings. Instead, this responsibility is delegated to science communicators who work to ensure timely and accurate reporting to the public about scientific matters. Science communicators also must determine how to best inform the public, including what information is shared, how it is shared, and when it is shared. With the growth of research capabilities, data will accumulate to either support or oppose existing observations and conclusions over time, and the public's knowledge must also be updated. Scientific communication is taught and offered as a major for some universities. Government involvement. The U.S. holds an abundance of power and wealth in science and innovation. This desire for innovation is embedded in U.S. history and is occurring at an increasing pace. As new discoveries are made, government institutions must guide and regulate the uses of this information as well as educate the public of the matter. References: https://sciencecommunication.gmu.edu, https://issues org, Scientific Controversies as Proxy Politics, https://www.merriam-webster.com/dictionary/controversy, https://ncse.com/library-resource/engaging-controversy-science-education, https://www.ucasais.com/essays/philosophy-and-approach-of-scientific-knowledge-philosophy-essay. PHP See also: History of the race and intelligence controversy, Biopsychiatry controversy, Causes of ADHD, List of scientific priority disputes, List of scientific controversies, Science, Scientific method.